Okay, now, page 5 is a lab exercise. That's for you to play with on your own. And I will give you the correct answers a little bit down the road, but I want you to go ahead and play with that one for a little bit and just get up to speed with it. But for purposes today, we'll go to page 6, and we'll get into the real meat of this, is converting numbers in standard notation to scientific notation. This has again been a real trouble spot for a lot of students, and this is what I came up with. At the top of the page, you'll see you've got a big block letter L and a big block letter R. So what I want you to do is I want you to put an arrow like this on the L and an arrow like this on the R. Get that one burned into your DNA, okay? That's going to be important. All right, so here we are on page 6. So converting numbers in standard notation, remember that's plain old bare naked numbers. If the decimal point moves to the left, the exponent goes up. If the decimal point moves to the right, the exponent goes down. Okay. Converting numbers in scientific notation to standard notation. That means you're going to be manipulating the exponents first. So, if the exponent moves up, that means the decimal point is going to move left. If the exponent goes down, then the decimal point will move to the right. There's also a cheater rule for standard notation. This is going to help you. Any number in standard notation can be expressed as itself times 10 to the 0. Because remember, 10 to the 0 equals what? 1. Okay? So if you've got a number in standard notation and you want to dress it up and make it look like scientific notation, just slap a 10 to the 0 on it, and then you can move from there. Now, general rule for correct scientific notation. And this is drinking tea with your pinky out stuff. You want to have only one digit in the coefficient to the left of the decimal. So fill in these blanks here. Only one digit in the coefficient to the left of the decimal. Now, very important exception. It is often more convenient to ignore this rule during actual calculations. So in other words, what I'm saying is, if you're working through a problem and you have 26.83 times 10 to the 5th, leave it like that. Don't change it if you've still got more calculations to do. All right? Otherwise, you're just going to be introducing too many moving parts. Save that to the very end to put it in correct scientific notation. So let's try a few here. We're going to convert 873.463 into correct scientific notation. So the number is 873.463. All right, that's a number in standard notation. I'm going to slap 10 to the 0 on it just so I got a reference point. Now, how do I want the coefficient to look? Well, I want it to have one digit to the left of the decimal point. So I'm going to bump that over 2 places to the left. 8.73463. So I went to the left. That means the exponent's going to go up by 2. There you go. All right. Example number 2. I'm going to convert 0.00785 Now I'm going to slap a 10 to the 0 on it just for a reference. Alright, so I want one digit to the left of the decimal point, so I'm going to bump it over 1, 2, 3 to the right. That's going to make it 7.85. Okay. Now I went to the right, that means my exponent's going to go down. I went 3 places, so that'll be 10 to the negative 3. Third example is one that's a little bit more typical. So you work through a problem and you wind up with 56.98 times 10 to the 5th. Okay, so it's not quite in correct scientific notation. Here's how I want the coefficient to read. I want it to read 5.698. So to do that, I went over one space to the left. So the exponent's going to go up by 1, so that makes it 10 to the 6th. And there it is. Now, I'm going to pause here and go through the lab exercises. First, we'll do the lab exercises from page 5. And if you haven't done them yet, then go ahead and hit the pause button now and go ahead and try them out. And then once you've gone through them, hit play again and we'll go through these. So I'm assuming that you've hit the pause button, so here we go. 3.8 to the 0 power. That's going to equal 1. 3.8 times 10 to the 0 power. 10 to the 0 power, that equals 1. So 3.8 times 1 is 3.8. 3.8 to the first power is going to equal plain old 3.8. 3.8 times 10 to the first. Well, 10 to the first is 10, yeah? So 3.8 times 10, 38. So these first 4 examples I put in here just so you can see, you know, there's some, they look similar, but there's some easy places to get a little confused here. So that's why these 4 are here. So continuing on. All right, so okay. So the next one is 5 to the 3rd in standard notation. Well, that's 5 times 5 times 5. 5 times 5, 25 times 5, 125. 672 times 10 to the 3rd in standard notation. Well, that would be 672. 672,000. 10 to the 3rd is 1,000. Okay. 6 to the negative 2. A couple of different ways we can answer that. We can go like this, or we can even do this. Both of those are correct. Okay, in the expression 3.12 times 10 to the 4th, I believe it is, yeah. The 3.12 is called the coefficient, right? 9.36 to the negative 1. I deliberately put that one in there to see if anybody got tripped up. 9.36 to the negative 1. Remember, a negative exponent means you're dealing with a fraction. So that means it's 1 over 9.36. Next one is x to the 5th times x to the 7th. The answer to that would be x to the 12th. Y to the 6th divisicated by y to the 4th. That better be y squared. 58 to the 0 power equals 1. 87 to the 1st power. 87 all day long. 2.38 times 10 to the 0. 0, that's 1. Definition of an exponent. It's an instruction, don't forget it. In the expression 8.75 times 10 to the 7, the 10 is called the base. Right? A negative exponent indicates you're dealing with a fraction or a decimal. All right. And the last one. All sorts of possible answers to this one. We have 5 to the 15th times 5 to the negative 17. And so that's going to equal 5 to the negative 2, which equals 1 over 5 squared, which equals 1 over 25. Okay? And if you want to go ahead and bash it out, it becomes 0.04. Okay. And that takes care of page 5. And now, page 7, some exercises for you. Again, go ahead and hit pause. And assuming you've hit pause and you've done the exercises. So, these first numbers, we're going to convert them from standard notation into scientific notation. So, 186,000, that's going to be 1.86 times 10 to the 5th. 0.0045. All right, we're going to go 1, 2, 3 to the right. That's going to make it 4.5 times 10 to the negative 3. 5,280, that's going to be 5.28 times 10 squared. 34.78 times 10 to the 3rd. So we'll bump that over one place. That makes it 3.478. I went to the left, so that's going to go up 10 to the 4th. Okay. We have, let's see, 783.487. Times 10 to the negative 8, I think. Yes. Okay, so we're going to change the coefficient to read 7.83487. So I went 1, 2 to the left. All right. That means my exponent's going to go up by 2, but I've got 10 to the negative 8. Well, think of a thermometer. We're 8 below 0. The temperature is going to go up 2 degrees. 10 to the negative 6. All right, 2.85. Well, that's easy. We'll make that 2.85 times 10 to the 0. Piece of cake. .000859 times 10 to the negative 9. Okay, so we want the coefficient to read 8.59. To do that, I went 1, 2, 3, 4 to the right. So if we go to the right, that means the exponent's going to go down. Again, think of a thermometer. It's 9 below 0. It's going to go down another 4 degrees. So now we got 10 to the negative 13. We got, let's see, 0.0835 times 10 to the 6th. Okay, so I want it to read 8.35. I want 1, 2 to the right. So the exponent is going to go down. That's going to make it 10 to the 4th. Okay, 0.00. Do that again. 0.0000, 4 zeros I do believe. Yep, 386 times 10 to the 12th. Okay, so I want that to read 3.86. 1, 2, 3, 4, 5 to the right. Exponent's going to go down. That makes it 10 to the 7th. Okay, here I've got 73.96. Okay, it's in standard notation. What can I slap on it? I can slap 10 to the 0 on it, just for a reference point. How do I want it to read? I want it to read 7.396. I went to the left, times 10 to the 1st. Okay, this one I threw at you to see what you do with it. 1 over 4. Well, you bash that on your calculator, you get 0.25. I'll slap a 10 to the 0 on it, and now I'll make it 2.5. I went to the right, times 10 to the negative 0.937. Okay, it's in standard notation, which means I can slap 10 to the 0 on it. I want it to read 9.37. I went to the right, times 10 to the negative 1. Okay, now, the next four are we're going to take numbers that are in scientific notation, and we're going to put them into standard notation. Now, here's the way you kind of cheat this one in the back of your mind. Standard notation is 10 to the 0. All right, keep that rolling around. Make that an earworm. Standard notation is 10 to the 0. So my first problem is I have 1.63 times 10 to the 3rd. Okay, it's in scientific notation now. I want it in standard notation. Standard notation is 10 to the 0. So to go from a 3 to a 0, am I going up or down? Well, I'm going down. So if I go from 3 to a 0, it means my exponent's going down. That means my decimal is going to go to the right. How many places? 3. So 1, 6, 3. 1, 2, 3. 3 places right there. I got, for the next example, I have 3.637 times 10 to the negative 1. All right. I want it in standard notation, which is 10 to the 0. So from a negative 1 to a 0, my exponent's going up or down? Well, it's going up. And if it goes up, my decimal moves left. There it is. .94 times 10 to the negative 6. Okay, I want to put that in standard notation, which is 10 to the 0. So from a -6 to a 0, is it going up or down? Think of a thermometer. 6 below 0 goes up to 0 degrees. Yes, it's going to go up. So if it goes up, if the exponent goes up, the decimal goes left. How many places? 6 places. And the last one. $36.345 times 10 to the second power. Okay, so I want to put it in standard notation, which is 10 to the 0. From a 2 to a 0, exponent's going down, means my decimal is going to go to the right, so my answer is 3634.5. There we go. All right. That'll keep you busy for a little while.